got time on here? So I'll go ahead and I'm going to start with a new mass instead of the generic model. I'll go to conceptual mass. By default, I have a template for that. Now you'll know you're in the massing environment when you see the gradient on the project. You'll see the purple reference planes. So really the only time you see purple reference planes is in the massing environment. All point data is purple, so it's a visual cue to let you know when you're in that environment. If you're in the family level of something, you're going to see green reference planes, right? So that's a cue that I'm in a family template versus the mass modeling template. So we want to be in the mass modeling template. Let me get back over to that. Right, and by default I have 2 reference planes. So if you did the homework, which you should have learned a little bit about this stuff. So who here didn't really get anything with that? Does anybody need me to go over that again? Simple basic editing. I think everybody got that. All right, so I want to set up a parametric relationship with this. So I have a basic file browser structure inside here. I can go ahead and I'm going to go to level 1. And then in level 1, I'm going to do an RP for reference plane. I'm going to put one on the one side, one on the left side, one at the top, and one at the bottom. And I do that because I want to bring my geometry in at this center intersection point. And I know that's the center intersection point because I'm working with it. It basically gives me a named reference plane. So we'll get into other classes later on as we go, what it means to have something other than the center plane and the right plane, what a weak reference is versus a strong reference, when to name one of those things and when not to name one of those things. For us right now, all we need to remember is that the 2 named reference planes are their intersection point is my 0, 0 marker. So when I load that into the project, I'm loading it in at 0, 0. If I wanted to load it in on the left bottom corner, I would move all of this parametric data that I'm doing up to the right of that intersection. The next part of this is to make an equality constraint. So just like we moved the level line and it moved the mass floor, and then the floor was hosted to the mass floor itself, that hierarchy exists the same way in every type of family or any type of modeling operation that you're going to do inside of Revit. So we use these as our construction planes. And then the dimension strings themselves serve as a way to host parameter data that we can later change and input onto. So to put a simple equality constraint on this, I'm going to do DI for distance. And then I'm going to click on the left reference plane, and then the middle one, and then the right one. And I'm going to drag off to the right into the white space, and click, and that releases it. And then I get this equality area right above that. If I zoom in, it's just going to stay getting small. If I click on that, it's going to make this distance equal to this distance. And it's arbitrary because we're going to use this later to define what we want it to be. And really all that's doing me is that if I move this plane, it's going to flex the plane to the left the same distance as that one. So I use the equality to lock it. I don't want to click. Uh-oh. Let me pause that. Right, so whatever you do, don't hit the lock button, because if you lock it, all of a sudden that's not variable anymore. So if I click lock, now when I go to move this, right, it's going to give me an error. So we don't want that. Right, so I just want to make sure it's there. Now if I lose it, right, all I have to do is click on the dimension string again, and if I click EQ, it's going to release it and then bring it back. So that's what I want, and then I want to put it on the right side as well. So I'll do DI again. Click on the top, the middle, and the bottom, drag off, and then I'm going to click EQ. So then that'll work for the length and width property. Okay? So now before I begin really modeling anything visual, I'm setting up a parametric relationship. I'm setting up the skeleton, right? So I think of my body, right? My body has skin, it has muscle, it has fat, it has tendons, and then it has skeletal bone. So that skeletal bone is kind of like these reference planes. And then on top of that, I build muscles, right? So my muscles don't move until my bones are moving. And then vice versa. They work kind of dependent on each other. So I'm really just developing a skeleton for my box, right? So the next part is I want to put a height eventually onto my box. So I'm going to go to my my north view, and by default I see a level line. We can talk about the difference between that. All that level line is really, in Revit terms, is a reference plane that gets a tag on it. So always think of the level line as almost like a reference plane. It's just that this reference plane is affording you a construction document capability of tagging your elevation. Don't think of it anything else. Right, so I want to put a height on my box. I'm going to draw in a new level, so I do LL, or I can do RP, but LL, since we're in the massing environment, always works a little better. I drag and put that in. Now what's nice about that versus the generic modeling family is I can put a height on this without putting a height constraint on. So we're going to do it 3 ways that I can control this height inside the massing family. The first way I can control the height of what my eventual box will be is I can click on the 100 foot or wherever you may have put it, and I numerically type in 50 feet. Right? But that's not really teaching us anything. We want to learn how to do this on our own in any family, right? Because not every family is going to have that little level marker, right? So that I'll use that same idea of constraining a dimension to control my height parameter right here explicitly between the 2 level lines. So I'll do a DI for distance, and I'm going to click on the bottom one and go to the top one, click in the white space to release that dimension. Remember, don't hit the lock button. Anytime we're setting up parameters, we never want to hit the lock button. And now I need to set up something that defines the way I'm going to make this box change in height numerically, because I don't want to graphically push and pull this anymore. I want to change it numerically. Right? So I'm going to click on my dimension string, and on the label there, it allows me to assign parameters to that dimension string. Now, because I selected dimension first, it's going to give me a dimensional parameter. But I have the ability to make all kinds of different parameters available to me. I can make material parameters, identity data parameters, just simple text parameters where I'm inputting text. All those things are available to me, and all those things we'll talk about throughout this sequence of the course. But the biggest and most important one we're always going to talk about is this length parameter. And that's done by just selecting the dimensional piece and adding the parameter to it. And now, there's a few other things, and as we get more advanced, we'll talk about shared parameters. It's a very powerful tool to use shared parameters. And then types versus instances. So this is probably the biggest challenge for everybody to understand, is what a type is versus an instance parameter. Right? So a type is like a block in AutoCAD. If I change one block in AutoCAD, all the other blocks that are copies of that block are going to change and do the same thing. Now, if I explode that block and then make a new block, but it looks the same as all the other blocks, and I change that one singular block, it's only going to change that one specific piece. Right? So that's called an instance parameter. An instance parameter operates on the level of the singular element. The type parameter operates on the global function. So my understanding and how I've gotten used to doing this is I always avoid instance parameters at all costs. And believe me, there's easier ways to handle it. There's only certain times where we'll use an instance parameter. And we'll talk about that when we do shared parameters. So this instance parameter goes right along with shared parameters. So for now, always use type parameters. And then we'll make different types of this box that are going to act like instance parameters. So I just always use types, right? It makes my life a lot easier when things get really complex in the project. Right, so that's the spiel, the little introduction to that. Right, so I just want to keep it simple for now, and I'm going to make it a height. So I type in height on there. I click OK. Right, so I have my height parameter. Now, when I want to change that, if I click on it or I try and move this, right, it's going to allow me to flex it, but that's still not letting me to put in a numeric value, and I can't just click on it and put in my numeric. Oh, I guess I can now. Oh, that's so cool. So I guess you can do that now, but really we want to begin thinking about setting up this piece ahead of time, right? So the last place I can do this and where I'm going to set up the other parameters is I can obviously go into my floor plan and I'm going to put on dimension strings, and I can do that same process with the height, but I'm not going to do that. I'm going to do it through the editor itself. So right up here at the top left is this properties area. I'm going to click on that, and then you'll see my newly created height parameters here, and I can use this to define different typologies of my set of parameters. So in this case, I have height at 150 feet, and if I click apply, it would have moved my piece. Well, let's say I wanted to have two different heights happening at the same time. Right, so the question was, where did I get one? The button was where we had it in the button. The second question was, where did I get the properties again? So in this case, there's two ways to access the properties. One would be selecting the dimension itself. Or two, in this case, I know that I'm going to put on a length, and I know that I'm going to put on a width, right? So I can do it through my family editor, my family type editor. I call it my parameter editor. And if I click on add with this, I get that same properties window. So in case you missed that in class here, again, it's just the add button. Right, and I'll make one for width. And then I'll make another one for height. Oh, height's already there. I'll make one for length. And I'll make, I'll just give it arbitrary kind of lengths for now to begin with. And before, I'm still doing a lot of planning before I'm doing this. So maybe I want to look at a box or a form that's 100 feet by 100 feet by 200 feet tall. Or actually, let's do 50 by 50 by 50. So I can make two iterations of this same box occur without me drawing two boxes, right? So I make a new family type, and I call it box B. I'll make a new family type, call it box A. Right, so box A and box B right now both have the same data into it. But I wanted box B to be 100 feet by 100 feet by 100 feet. So we'll make a cube with it. Right? So now when I toggle between box A and box B, my numbers change according to what type I'm using. So now when I go, you can imagine the power behind this is if I had like 10 iterations of forms I wanted to analyze, right? Maybe I'm doing little blocking diagrams for a program, right? And I know that I have an office at 200 square feet or 150 square feet or 100 square feet, right? I'm doing tests, and I want to see what forms are going to afford me different layouts right inside my project. I can go and I can set up all that iteration data right here in the project before I even draw one box. Then I draw one single box, and it pumps out all the other boxes for me at that type, and I can toggle in between them at any time. So that's really the power behind it. It's kind of like primitive computer programming, what we're doing right now, right? So before we're even getting into really complex things, we've basically just written a visual script for ourselves. So that's the first one hopefully you've done, or maybe it's the second or third, or maybe you're a genius and you should be teaching instead of me. I don't know. But so that's your introduction to computer programming in Revit. So I was just going to click apply and edit that one. Click OK. Right, so now I have almost all of my skeleton figured out. I have two family types. I need to put on a width and a length parameter. So the last part is the backwards version of what we did to put the height on. I do DI for dimension, and I'm going to go and I'm going to type in there, put one on the top and one on the left just above my two equalities. And on this one, I'm going to make that my width by clicking on the label area, and then this one is my length. Width, and let's see here, is my length not coming out? So something must have happened with that. I might have had a lock on here, so it looks like it's still working though. So something happened where I got constrained, but that's okay, it's stuck. So now I have two sets of this. So if I toggle in my family editor, and again the family editor is right here at the top area where the R is. There's the properties area of the modify ribbon. the bottom right button of that square. And if I look at and bring that over, and I'm going to look and see what happens when I flex my model. If I click on A, and I'm going to click Apply, I can see now that's changing for me automatically. I've set up 2 types, and I didn't have to draw it twice. Okay? So you want to make sure that that set of stuff is working for you. And then what's only thing that's left for us to do is build our box on top of our geometry. So that comes with a whole other set of problems that we're going to have to do. All right, so it's got time. Good. So what I'll do is I'm going to make a form. So we should be familiar with how to make forms in the massing environment. Under that same modify ribbon, I have I'm going to pick a rectangle because rectangles work best for rectangles, for squares. I'm going to click on the right point, and then at the bottom, or top left, and then the bottom right, and then I get these 4 lock buttons. So the time you want to use the lock button, so this is the lock button here, right? The time you want to use the lock button is when you have geometry sticking to the reference planes, right? We're not locking dimensions, we're locking geometry to the reference planes. The reference planes are then locked to the dimension themselves by the parameter. So before I stop drawing, I'm going to click and make sure that those are locked. So that gives me my line, or my square. And then I always want to, every step I take when I'm setting up this parametric relationships, Revit wants you to kind of just look and see that your operations are still working. So I'm just going to toggle in between those two types I made and make sure that my lines are still stuck to the reference point. If they're not stuck, right? So maybe I had one that became unstuck. So I'm just going to click OK. Maybe I'm going to move that over, and I'm going to remove it. So let's say in this case you had something happening where I got 2 of them aligned and then the other 2 are off. So I apply. It's only flexing my top and bottom. So that's going to happen. That means that you forgot to lock the button, right? You forgot to lock the lines on the button. So what I can do is I can use my align tool, which is AL on the computer, and that works for everything. Anytime I want to lock another object to another piece, I'm going to use the align tool, which is AL on the keyboard. A is in Adam, L is in Lori, and I'm going to click on the item to be aligned to, and then the item I want to align, and then I can lock it again. And then I check my toggles, I click apply, and again they're locked. So you know, you're gonna mess up. You're just knowing how to fix what you messed up. So I said Adam and Lori. So I'm learning my military language. So I gotta think of Alpha, Bravo, Charlie, Echo. See, this is why I'm not learning, because somebody always chimes in. What is it? Lima? Lima. L is Lima. So Alpha Lima. Damn it. Okay. So now I want to put a height on this. So before I can put a height on it, I really got to extrude out my geometry. So I'm going to go ahead and just click the Create Form button, and then I should see my object go gray. Now if it's not gray, it means that your graphic properties are not on. And then I'm going to go to my 3D view. So now in my 3D view, all the stuff that we set up now that was so nice and clean becomes this like really, really nastily jumbled mess in the Revit environment. So what's happened now is because the massing environment is so loose, right, I need to first align the top of my object to my level line, which my level line is here. I can see that highlighted by clicking on it. So I use my align tool to align that so my height sticks. I'm going to go ahead and click on the level and then click on the top and lock it. And then I've made another operation, so I'll go back and check my relationship and make sure it's flexing still. And whoops, oh my goodness, it broke. So because Revit is so kind of loosey-goosey sometimes in the massing environment, it wants you to really think about every parametric relationship at all sides. So we never really snap the surfaces to any other reference planes. So I need to go ahead and make sure that my sides are also snapped to the right reference plane. So even if I had, even though I drew it here, it didn't align the top edge of those boxes. So it wants all pieces to be aligned and constrained. The way around that would have been to draw the same piece of geometry at the second level with the same constraints, so that I wouldn't have to do what I'm going to do next. But it's good to know what you can do when it breaks. So again, I just use my align tool. I'm going to undo what I did first, actually. I'm going to use my align tool to align every side to its corresponding reference plane. Oops. Missed it. There you go. And it might be already snapped, so there we go. So now that I did that, I'm going to try again flexing my model and see where it breaks, because it's probably going to break. It always does. Oh, nope, we're good. So there we go. Now I have my box, and I can make as many iteration types as I want from this box, and it's going to do what I want. So if I wanted to make a box C, I'm going to click on my types, and let's make a new type called box C. Click OK. And then this one's at maybe 200 feet by 100 feet by maybe 25 feet. So it's like a low-lying building. Right? So now at any time I want, I can toggle. At least right now, I'm toggling through the family editor. When we get to the project, I'll be able to cycle that as if it were a wall. So if you've ever changed the wall type in Revit, right, that's basically what's happening in the wall type. You just set that up now for yourself. So knowing how to do this, you should be able to walk into any single family that exists already currently as a system dialog, anything such as walls, windows, doors, floors, stairs, anything that you can click a button for, and you're going to know how to edit that in the Revit environment, right? Because this is exactly what's going on. And now you can do that for yourself because you built your own box. So that's why I always lead into this first instead of trying to show you every little piece of like, hey, here's a door, here's a window. Everybody can make a door and a window. You make a wall, click on door, put a door in there. That's not what Revit is. Right? So I'll click apply and click OK. Some other things we can do. So we're going to like really juke this box out. We're going to make this like the Ferrari of boxes in Revit. We're not to the Cadillac yet because we're not old and you know, I don't know how many people like pink, but I don't like pink Cadillac. Has anybody heard the old song, the old Pink Cadillac song? Or am I just like that old? Anyways, so what I can do is also in that family editor, I can put in, right, basically all I've done is associated single dimension variables to each one of those parameters that I set up. So the second box over, it says, now I'm going to put in a formula. Right, so now I can begin setting up relationships. So let's say maybe I don't want to go over a certain area for my floor plate, right? So let's go ahead and add an area parameter. And in this case, I went too quick, so I want to remove it. If I've already clicked OK, I want to remove it. And there's something specific we need to look into. These are dimensional parameters. I need to make my area calculation instead of length by default. I want to make it of an area type. And what that's going to do is it's going to change my units to be square foot versus singular foot with a length parameter. And it'll allow me to do a calculation of all of these length ratios for me. And I'm going to call it area, or I'm going to call it floor plate. Whatever you want. And then you'll see it gives me the unit base of square footage. Right? So let's just give it let's go to box A with that. And on box A, we're going to say that I want it to be 100 square feet. So within this, I'm going to say that I know that maybe I'm making this an office unit, right? It's just an office. Right? I want an office to be 100 square feet. So 10 by 10 makes an office that's 100 square feet. Well, what if my width is constrained to say, well, I know that I need 25 offices in this line, and my line is 100 feet. That means I only have 4 feet for every little office, which is super tiny. That's like enough room to walk in, hang your coat up, and then I don't even think you have room to hang your coat up by code. So, well, that's an example. So I would choose one of these variables, either the width or the length, to be my driving principle. I'll say that, let's just pick width. We'll say that I'm going to change my width, and it's automatically going to change my length according to whatever I told my area to be. Right, so I'm going to say that length is floor plate. Now it's crucial that you spell everything correctly, including spaces in this. Divided by width. Right, so basically these are the names of the variables. This is like basic geometry. So consider this is like x, y, z. This is z. Z divided by y equals x. Right? So it's just floor plate divided by width equals my length. So it's kind of a reverse idea. So if I click apply on that, it's going to change my box for me. So now it grays it out, so I can't change my length parameter anymore. My length is dictated by both the floor plate and the width. Okay? So if I change my width to be 10 feet, I should get my length to be 10 feet as well. When I click apply, it's going to change that. Or if I want my floor plate to be 1,000 square feet, it's going to change it that way. So now I'm using other graphical inputs to drive that same set of parameters I have inside my object. The last part would be to tie in whatever my length becomes. I want it to be a divisible number of all the other things. So maybe I want to set up a 1/3 relationship with all these things. So I would put in a ratio value, and my ratio value is going to be a number, or it can be an integer. Let's do it as an integer first, and I'm just going to call it divisor for this. Doesn't really matter. You pick what you want. Right, and it shows up, and I'll say by 3. So then I'll say my height equals my length divided by divisor. And if I click apply, whoops. Now if you get that error, it means I got a space in there, so I don't want the space. Length divided by divisor. Oh, I know why. So right now I'm getting my error. So this is a little quirk about what Revit is. So I pre-made my height at a level of 100 feet, right? So there's going to be times where I make my height too big to begin with, and I can't drive anything smaller. And vice versa, sometimes when I start with something so small, I'm not going to be able to make it bigger in any calculation. So I'm going to say, in this case, when I say I can't find a solution for box A, I'm going to click cancel, and I'm just going to click, I'm going to turn off this relationship I set up, and I'm going to click apply. And then I'm going to start and click OK, and I'm going to remove my height parameter here, delete that off. Then I'm going to go back to my family, because I want to set that relationship up. I don't want to just quit and give up. I'm going to make it so that my length divided by my divisor should equal that. Make sure I spelled everything right. Still can't. So it might be that the divisor is also, I'm going to remove that. Let's make it a number instead of an integer. So it might be that it wants to be a number instead. So I'm going to add my divisor again. And then you try numbers. So sometimes, because it's beginning to be, so these are heights, right? So these are in foots and inches, or feet and inches and all those other things. My square footage shows me that I'm in a decimal form. And I was trying to do a division by an integer. So an integer is a whole number. So the clue to this is, well, if I can do an area multiplied, I should be able to divide by the same number. So I'm going to go ahead and do it as a number versus an integer. If I click OK, that number is now in decimal form, and I should be able to do 3.0, and then I should be able to do length divided by divisor, and then I hit enter, and then it works. So the error there was, it's always good to pay attention to the units. So in this case, my area was in decimal form, and I was able to have a successful calculation happen. So now I obviously need any type of division happening to be also by another decimal. So I had that running in that line. Unfortunately, you have to stay consistent with the units. Yes? So I'm going to pause it and we'll go around and see this breaks. So I'm going to click apply. So then the last part of this is I solved that issue by basically reversing that idea, right? So instead of timesing it and dividing it, I basically just said, okay, I want to divide by 3, so I'm really just going to times by 1/3. Okay, so that's done. So the last part of this is I want to set up I want to introduce you to materials on this, and then we'll load it into the project and we'll be done for the night. So the same way that I put on the dimensional characteristics of this is I'm also going to put in visual characteristics as well. So I'm going to just go to my 3D view for this so I can look at my whole object. And I'm going to tab through so I select the whole piece itself. And then on the right, or the left-hand side of my screen, you'll see the properties window of this come up. And then it's going to say materials and finishes in one area. And then under material, I'm going to click on by category. I'm going to select the button next to it. So I'm not going to click in here. There's a little button right to the right of it. And if I click on that, it allows me to add a material parameter as well to this. Now, unfortunately, you can add parameters called material type parameters ahead of time and load them in. But to assign them to objects, it's always got to be through the properties of the object. So I always have to take this process with it. And I'm just going to add a parameter called visual. And I'm going to make it a type parameter. And I'm going to click OK. And then when I open up that material editor again, I also have now my visual under materials and finishes. So I can set up box A, box B, and box C to be all 3 different category types and visual types based on pieces. So maybe I'll make box A all red, maybe I'll make box B all green, and maybe I'll make box C all yellow. Right? So I'll click on box A, and I'll go to the visual and click on by category, and I'm going to select on that. And it's going to bring up my material editor. Now, my material editor is going to be different than your 2014 editor. But really, the only thing you got to think about with what a material is in Revit is that a material is just a container of data. It's going to contain structural data. It's going to control analytical data, like thermal properties and the such. It's going to have a visual appearance, and then it's going to have an appearance in the sense of construction documents, right? So it's going to have cut patterns, solid, hatch, brick pattern, whatever it may be, is all going to be contained in this material editor. And each version of Revit is going to handle that material editor a lot differently, right? So I'm going to go ahead and I'm going to select on, for this, the graphical appearance is going to be how it looks in a shaded view or a consistent color view. So I'll click on color, or excuse me, I'll scroll down, I'm going to go to surface pattern. And that pattern is going to be solid. And then its color is going to be red. And then I'm going to do the same thing for the cut pattern. So when I look at it in a floor plan, it's going to look as a solid fill, and it'll also show up red. So in 3D it'll look red, and then in 2D it'll look red as well when I click on done. And that is my chipboard. So I'll right click and rename my chipboard to be red. And to keep it so it stays at the top of the stack in my materials, I'm just going to do an underscore red so I can grab it easily. And click apply. And then the only way to make a new material in Revit is to right click on it and duplicate it. There's no way to make a new material. And that's because of the way Autodesk has encrypted this typology of handling materials. So I'll just double click on that, and I'll change my color now to be green. And I'll right click on that and rename it and call it green. And then I'll duplicate my green one, change it to blue. So then box A we'll make blue, box B we can make green, and then box C we can make red. Oops. So we're getting an error on this one too. So I'm going to delete box C here. But I'll just click apply. Well, why is that not coming up now? Oh, because I got 0 square feet. So on my box B, and that, you know what? That's probably why we're having an issue with the other ones. So when we had the devising problem, it's because I had never set a square footage on my other types. If I would have set a square footage on my other types, your calculation is going to work. That's kind of like a dumb moment for me. Sorry about that. So I'll just set that to be 150. And then box C, we'll make sure it has 200 square feet. So you can't ever have a 0 value in any calculation. It's going to end up breaking. Yeah, that's like my dumb moment of the day. I'm allowed one. Okay. So the last part is I have my pieces. All I have to do now is load them into a project. So I'll make a new project view. Go to my families, and then under mass I should see my pieces. Oh, I haven't loaded it in yet, so I'm going to go ahead and load it into my project. Project 1 is fine. And I'm going to do 1, 2, and 3 for each piece. And then if I select the 1, I can now change it to box A. And then this one can be box B. And then this one can be box C. Okay. And then next week, so let's save that file. We're done for the day. All right. Okay. So while my Revit's firing up here, I'm going to fill the lights. Hopefully you have Revit open. Again, to remind you that we haven't upgraded at Harrington for 2014 yet, so I'm stuck at 2013. Be aware that is everybody in 2014 here? Okay, so yeah, be aware when you're working on your laptops and you want to match versions. I can't go backwards. I usually try and stay back on my files for a little while. Usually I'll wait till the first service pack gets released before I upgrade Revit, but we're almost to 2015, so I should do it. So either way, I'm still working in 2013 on this. They're basically the same. I think there's only a few things that changed in 2014. Things that changed were, one, how we do stairs in Revit. Another thing that changed was the material editor again. So every year they change what the material editor looks like. All the same stuff. Looks the same, does the same things. Their buttons are just in different places. And I think for today we'll touch a little bit on at least the material. So I'm not too sure if we might get tripped up because of the different versions, but I really don't think so once you understand the concept behind it. So for right now, it's really that a lot of you are, at least in my experience, everybody comes in and there's always a certain tool to achieve a certain task, right? So for me to do a mass form like this in Revit, you know, it might be challenging. You know, it might take me a little bit longer of a period of time to do it than it would just to you know, throw it together in SketchUp, stick it into Revit, get what I want out of it. So I always like to show you how to navigate the waters in and out of softwares. And in this case, our primary focus, at least for part of this class, is Revit. So I want to show you how to take, you know, what you may be used to using and get it into the Revit environment, and how we can use those other tools and leverage them in the other software program to do things that we want it to do. Right? So I have my SketchUp file. Really, at this point, Revit will take SketchUp natively, so I really don't have to do anything funny with it. I can save it as a SketchUp file. So right now, you'll have this tonight. I'll just put them up on the website so you have these files to work with in case you want to practice on your own. I'm going to save that as my high-rise scheme, my high-rise mass. And that's my SketchUp file. Maybe later, I don't want to share it. I'll share it with you guys. And then in Rhino, you know, any kind of double curved surface, which I have here, right? We could assume that this is a cosine curve mathematically, or whatever you want to do. Really, all I did was draw a few arcs, and I got the form of the surface I wanted. Or I might have produced it with Grasshopper and baked it into Rhino, and so I have my surface. So to do a surface like this in Revit, it's really, really difficult, just because of the mathematics behind the way Revit models or achieves its modeling environment or pieces. So I can use other geometries from other softwares to really get what I want out of the Revit environment, and I'll read it. Again, to do this in Revit, it's really a challenge. So I do those things in Rhino, and I'm not, you know, super religious about only using Revit. So you can use other softwares, right? So just be aware, you know, there's always a tool to do a certain thing. Now the trick with this is there is direct imports for NURB surfaces now for Revit. We're not going to go into that stuff. I'm going to teach you the way I know to do it. Really, it's great. I can download all kinds of plugins. Same thing with Grasshopper. I get all kinds of new plugins all the time, and they're great. They're new tools to use that facilitate certain things. But it becomes a point where, you know, you spend more time trying to keep up with all the new stuff. They're really not just focusing on learning the things that are there for you, right? So just learn what tools are there, and then you'll just naturally progress into all these plugins that are available, because you'll be looking for a new way to do something, right? So instead of trying to learn every new thing out there, learn the basics, and learn all the guts, and then go from there. So for this, the process goes is that I know that Revit, you know, if I look at what Revit takes as an import, maybe I'm going to start a new, in this case, I'm going to start a new family, right? I'm going to start with a mass family. And I'm going to be taking each one of these objects into the mass family first. So we'll just open that up. And I want to look, and anytime, this goes for any software, when I'm trying to navigate the waters in and out of software, before I go thinking about writing my own tool or looking for somebody else that's written a tool to do it, I'm gonna see what's available to me in the one software and what's available to me in the software intended to go to. So if I go to my insert ribbon in Revit, I have this import CAD feature. So CAD is not like AutoCAD. It really means all different file types. So by default, it does give you a DWG, but I can also look at what other file types it allows me to import natively. And what's great about Rhino is it's this kind of like universal tool for modeling. It'll go in and out with a lot of different software. So I have DWG and DXF, those are your CAD file types. Right? DGN files are for MicroStation. So if you use any Bentley products, ArchiCAD, all those things, those are your DGN files. And then your ACIS is an SAT file. You're going to use this both as a CAD solid, so this will be a CAD solid from AutoCAD, and Rhino will also export an SAT file type. So we know that I can use the SAT, right? And then of course SketchUp, it takes SketchUp natively. So I can use all of those types. So then I'll go and say, okay, well, I need to now say, hey, I know where I'm going to pull from. Let's assume I didn't know. I would go to this surface and I'd say, okay, Rhino, what out of those 4 types will you give me? And if I go to export, selected, right, I know that Rhino's going to export CAD, but it's going to be a mesh and it's going to be really nasty. So I'm just telling you right now, it's not the right way to go. SAT is nice because it's a nice, smooth, clean surface, right? So I'm going to look and see if Rhino does an SAT file. And it's going to be ACIS, SAT. So right there. So Rhino does do it. I thought Rhino changed. It's going to be a little scared there for a minute. So yes, it does do an SAT file type, and it does export that. So I'm going to export this surface as the SAT file. So I click on it. I'm going to put it on the desktop here. And I'm going to call it wide span surface. And default's fine for it. And then that's it. That prepares both that file and the SketchUp file. So hopefully I saved my SketchUp. I did. I'll save my Rhino file so you can use it. Sure. Wide span surface. Right, and then I can close Rhino. I don't need it. So then the reason why I do it in a massing environment is because if I were to put it in a project, I'm pretty much stuck with what it is. I don't have the ability to edit it or do anything. So with specifically the high-rise building, and what we're going to do today is we want to use that building mass to begin cutting floors. And from those floors, we're going to be able to pull area calculations. So we can do a quick overall estimate of if we're building a new building, are we hitting our overall scope for that building? You know, because that all has to do with the cost of the building. And really a lot of this class can be focused on, you know, cost associated things. Because really the main driver of all real estate and all buildings is not the intent to have a beautiful building. That's like secondary. It's because there's some other need that somebody needs to build a building, either expansion of a business or expansion because there's, you know, no rental property, so you see a ton of residential high-rise going up. So it's always financially driven. So the more we as architects can give them alerting to that financial data, right? Or at least being cognizant of that when we design, the better off we're going to be. And, you know, big CEO types are going to love you because you talk their language then. You're not just talking color schemes with them or form. Okay, so I bring it into the mass family. So we'll start with the Rhino surface first, because that's the fun one, I think. So all I do is I open up the new mass environment, and I can do it in a generic model too, but I would have to do the generic model to the mass, to the project, and I want to do this as least amount of steps as possible. So what I do is I'm going to go ahead and import my CAD again. I'm going to take my SAT file. I'm going to find where I put it, and I believe I put it on my desktop here. Wide span surface is my SAT. Now, some of the things to be aware of here at the bottom, right? It's going to say, and you should do this at all costs. You should always read the options that are available to you. So colors are going to preserve. So if I turn my surface green in Rhino, it would make it still green in Revit. You know, my layers and levels. Well, I'm not importing anything with layers per se. Well, Rhino may have layers, so the SAT file is not going to have them. There's definitely not going to be anything instructions in it, unless it's a DTN. And then my import units. It's going to auto-detect that, so I don't have to scale it. Because sometimes there's a scaling problem in Revit. So I just leave everything where it is, auto-center to center, place at level 1. And usually the default's pretty good. So I just click OK. And it'll chug for a minute. It shouldn't chug too long. And Revit pops it in there. Right? So it loads it in 0, 0. Right? And now all I can do with this file at this point, if I loaded it into the generic modeling family, I'd be able to do things with it. If I tab through on the file, right, I can at least build new geometry off of that. Well, in this case, it's not going to let me. If I would brought it in from the generic modeling to the mass, I'd be able to build some geometry off this if I needed to. But in this case, I'm just going to use it for a divided surface or apply a curtain panel or something simple in Revit to it, because right now I can't really do anything. If I try exploding it, right, it's going to explode it and there's going to be nothing there, because exploding only goes for 2D data, right? One thing I can do is, let's say I just wanted the lines. Maybe I got the surface off of some website and I just wanted lines off of it. If I did a partial explode, well, in this case it didn't even do the lines on that side. So sometimes it'll actually give me the outline of what I had. So usually at this point I really can't do anything more with it in the massing environment. So I need to make a new project. So I'm going to go ahead and make my new project. And I'll start with an architectural template. And I'm going to go ahead and load that into the project. Right, so it's going to allow me to put it, and you'll see that it's already starting to cut a floor plan out of that surface. And then it gives me this warning. So if you did the homework and went through the tutorial for the homework, you may have seen this warning. It said, mass contains only mesh geometry which cannot be used to compute mass floors, volume, or surface area. So it's basically just telling you, you either have only line data to your massing element, or you only have a surface data. In this case, I don't care. I'm not trying to really generate any kind of floor areas or anything off of it. I would have extruded that and brought it in differently if I wanted to do that. Or I would have thought about modeling it differently. So in this case, I'm going to go to the 3D view, which is the default house up there for a new project. And again, I see my surface. So now I can actually begin doing some things. And really this is kind of a one-liner, but the process behind this and the reasoning behind this is really simple. It's that we're going to use the masses in our project to begin driving all the other data that we use. And we drive masses with reference planes. So there's this hierarchy of systems, hierarchy of programming. One thing controls another thing, controls another thing. And we can build really complex parametric systems pretty easily just by following this hierarchy. So I'm going to use this surface only as a hosting element for something that's native to Revit. And the coolest one I found to do this with is the curtain system. Now the wall, because it's double curved, the walls won't come out. For some reason, Revit still doesn't like double curved wall system. So I have to do it as a curtain system. So I'll click on that, click on my curtain system, and then I have a button that says Create System. And I'll give it a minute, I'll let it chug through. So what it's going to do is it's going to subdivide this surface for me, and it's going to make Revit geometry that now contains glass panels in it. So now if I wanted to do a really warped surface, and maybe this was the idea of my structure here, I now see that inside my Revit project. And I can hide that Rhino import, and I don't need to see it anymore. So if I go through and tab through, I can right click, or if I turn on shaded view, I should be able to hide one and isolate the other one, right? And then this surface I can use, and I can pump in mullion data if I wanted, and edit this type. Let's say that's a 5x10. Maybe I just want structure, I don't want the panels. What I could do is say that my curtain panel is now an empty panel, and that my mullion type is something default in Revit. Maybe it's a 1-inch square on all of them. So it should change that and give me something more gridded, more waffle-like for this. Now you'll see that Revit's going to begin chugging through this a lot longer, because there's a lot more computation happening. And Revit, unfortunately, is not like 3ds Max or Rhino or anything else. It only uses one CPU core to do most of its processing. So sometimes it takes it a little while to process. In this case, we're okay. It did do it. Now I'm on a shaded view, so my glass panels disappeared, and I'm left with my rungs. And I can control those parametrically as well, just as I would with a grasshopper model. I can make them large, I can make them small. You know, each tool has its own intent, I guess, and method and reasoning. So that's the Rhino import. Anytime you do anything with Rhino, if you have any kind of wide span project, you know, that's something like this, I would think that you would try and do the surface in Rhino first. 3ds Max is an option as well. That's a nice NURBS modeler. It's pretty simple to use too sometimes if you know what you're doing. So that's that process. Now for the SketchUp model, I'm going to go ahead and I'm going to tab. I'm going to leave this as is. I'm going to tab back to my mass here so we see where that started. I'll save this out so you have access to that and say this is my wide span surface. Then I'll make a new massing family for my SketchUp surface. So the file, new family, and you'll notice since I close it, it still stays in the project. All right, now in this family, I'm going to do the same thing, but I can import native SketchUp elements into this file, so I don't even really have to worry about the export function or anything else. I'm going to go ahead and insert, import CAD. And in this case, I'm going to select SketchUp. I have my high-rise mass. Click on Open. It loads it in, right? Pretty much the same thing here. I think with SketchUp, because it's derived from a different type of modeling, that the explode function will work. But in that case, it still doesn't work. So again, it's always good to test and see if they changed it. It didn't. So I'll go ahead and I'll just import that into my project. So I'll load it in. And then I have my high-rise mass. Okay. If I go to my 3D view, I have my high-rise with my canopy. Maybe my canopy goes over this little area here, which maybe we'll do that real quickly. But really the same thing is here. Now it's differently because it treats it a little differently because now, and what we're going to get into for your homework, is really we want this container of a solid for our projects, because that container is going to allow me to begin pulling data off it, hosting wall elements, hosting curtain wall elements, and all these other things. Then if I went back into my family and I changed my model type, I would be able to update all those elements that I host to that file, and I wouldn't have to go and remodel anything. And that's really the power behind it. And I'm connecting it to data, so I'm always getting a real-time schedule when I'm doing my editing. So that's the really cool part. Just as there's some nifty little tricks you can do right away with it, the nifty little tricks you can do with this is if I go to my elevation view here, and I'm just going to array my level lines up. It's AR for array, and it's just like an array in AutoCAD. I tell it how far I want it, and then I tell it how many I want. Uh-oh. Oops, daisies. Sorry about that. And I say, okay. So then these levels, right, can exist, and I can leave them in the array. I'm not trying to make floor plans at this point on it. So I can adjust that accordingly. So maybe I want less spacing or more spacing. We can make parameters on that to adjust that on the fly. In this case, all I want to do is I want to begin thinking about, because I have a fairly irregular geometry out of my building itself. So to draw in the floor plate every time for every level, or even make one and copy it up, or maybe it's alternating, right? It becomes really difficult. I want to spend a lot of time making floor plates for my section, right? Especially if I'm just doing an overall section. So I just select my mass, and then there's this little button called Mass Floors. If I click on it, then all those new levels I made, I'm going to scroll all the way down, hold Shift and click on level 51, click OK. Right, and if I just let it chug through, it's going to cut. Oops. Maybe I forget to hit OK. Yep. Did it not cut it?
Your levels are
I don't think that's why. Maybe that is why. It shouldn't be. It might be because these are still grouped. So I'm going to filter that, and I'm going to say model groups. I'm going to check. Click apply, click OK. And I'm just going to ungroup those. And we'll try your idea here. See if that works. I don't think it does, but so go to 3D. So now I should be able to cut my mass floors. They might be turned off in my view. There we go, turn on mass. If I click apply, click OK. So I still don't see any of my mass floors. So I think I might be called a liar on this. let's say that's not something right. So in this case, what had happened was is I went and I tried to go through the mass family, and it should have allowed me to now cut floor data out of this mass. So in the event it doesn't work, that thing I talked about, I had to bring it into a generic modeling environment, then into the mass, and then into the project level. I think that's what we'll do, and I think that's what we probably have to do with SketchUp files. So I'm just going to delete that. I'm going to make a new generic modeling file. All right, I'll do the same thing that I did prior. Import my SketchUp file. Now I'm going to load that into my family number 2, which I had before. So now I have an equivalent piece, but now it should be a little differently. So this one is now a physical entity, where this is just a combination of pieces that are assembled as a package. So loading it in this way affords me a little different set of operations. Now it is something I can build geometry off of inside the Revit environment. So it's good we made the mistake. At least I got to show you this. I can still do the same operations I did with SketchUp, right? And I can load this into my project. So maybe I did half in here, half in Revit. I'm going to load that back into the project and click OK. Next, I'm going to overwrite it. So in this case, it's already existing in it. So I'll go to my generic modeling or mass family, for this case, mass number 2. Bring that in. Generic error has occurred. So let's go back. Let's go ahead and delete those operations we just did. Let's try it without the new data on top of it. There we go. So I have my piece. Go to my 3D. Looks like I'm locked out of it right now. Okay, so that's what's happening. Because of the way it was created in SketchUp, it's not allowing me to cut the mass floors on it, and it gave me that warning. So you'd have to be aware of what's happening with it. So I may want to go back and think about how I did that. So that error, because I did it that way, at least that time I got an error. So when I made the SketchUp file, because I did all the pushing and the pulling and everything else, right now it doesn't like the fact that all of this is cut in pieces, right? So maybe I just make the solid extrusion piece out of SketchUp. And to show you and illustrate that, I'll just go ahead and open SketchUp real quick and just prove my point. Right, in this case, we'll just make a box, simple. So I had all those cut planes and everything else going on. So that's a case where it gets a little too complex for the system. So I'll go ahead and save as. High-rise mass number 2. And I'll delete this off since I know it doesn't work. This one is just locked in there now, which is sad. Go through, tab. I can delete that off. So in this one, I wouldn't need to go through the generic model environment. I should be able to bring it right into the mass family. And it should import, or it should cut those floors. So and the only reason why I'm continuing on showing this, because I want to show you what we're going to do today. Because we're going to do this same stuff without the use of another software. So I'm just going to load that in. So then this one, hopefully, still locked for some reason. Bring in the second one here. There we go. So no warning, mass floors, and then this one should cut that floor data. So I don't think I've never really used or had to use this intent or use SketchUp to this level, because usually I just do it in Revit. So today we broke the SketchUp to Revit process for this at least. So that's good. We see the the implications of why you don't do that all the time. But what's nice is now I have this data from my SketchUp file. I now have floors, but I can host floors too. I can hide this piece inside my view, and I see now only my floor plates that I wanted. And now those are native Revit pieces that I can host floors to, and walls and everything else. So if I wanted to put a floor on those, I could. Can't see up here right now. So do a floor by face. Then each one of these will take a floor. And now I have a floor unit with a thickness. So I didn't have to go in and actually model a plane or a box. Take a box and array it up. Those are stuck to a level. So if I move that respective level up and down, right? So I'll go to my north view. Because it's hosted to that line, and that line is cutting my floor plate. Hide my mask here if I can. Let's just cut a section through it. Yeah. Looks like it's right there. So hopefully I'll just move that down, and if I go to my 3D view, you'll see that because it's hosted to that, because the level drives the max floor piece, and then the floor is hosted to the max floor itself, then all that stuff moves together. So I didn't, if I wanted to move it up, I kind of just grab and push and pull where I want it to go. All right, so that's the idea behind it. We're going to make our own little parametric box today, and we're going to put some data into it. We're going to do a simple calculation of length and width on it, and then we're going to cut it up. We're going to do some iterations. So we'll make one box, do a bunch of little different things for us, and we're going to analyze different sets with that. So it's called putting a schedule on it. Schedule is just a database function. Okay, so that's importing. Let's go ahead and stop the video.